session in the Student Development Conference 2021. I'm Mariette Harkum. I'm the chair of the Southern African Archaeological Student Council. With me today is my fellow member of council, or at least a shadow member until she decides that she likes what she's seeing and she's joining us, Mpumi Maringa, and then our very special guest for today, Keneiloe Molopyane. And without stealing any of Mpumi's thunder, because she's the host for today, I'm going to pass it over to Mpumi for a full introduction. Take it away, Mpumi.
All right, thank you, Mariette. So, Keneiloe Molopyane is a postdoctoral researcher at the Center of Exploration for the Deep Human Journey. So that's the CEDHJ at the University of the Witwatersrand. Keneiloe is an archaeologist and paleoanthropologist from South Africa, having studied at various academic institutions. She obtained her bachelor's and honors degree in archaeology from the University of Pretoria, her MSc at the bioarchaeology from the University of the Witwatersrand, and her PhD focused on how bone trauma found on the human skeleton can be used to reconstruct past lifestyles and activities. Keneiloe has extensive excavation experience in the Iron Age and early farming community sites in the northern regions of South Africa, as well as underwater archaeological experience from projects she has involved in through the Ezekiel Museums of South Africa, and also the African American Museum Smithsonian Institute. All right, Keneiloe is an underground astronaut working with the CEDHJ research team, exploring the Rising Star Cave System and the UW105 site in search for more fossil remains that will also aid our understanding of human origin. Right, so Keneiloe, you may start your presentation.
Thank you very much for the introductions. Let me load up.
Okay.
Yeah. Yes, thank you. I am Keneiloe Molopyane, and my talk today is on my PhD project, well, section of my PhD, and this talk is titled Fractured Bone-scapes, where I use spatial analysis to understand bone trauma in South African skeletal populations. So my main research aim was to try to see if I could investigate the long-term social trends of trauma, where I focus exclusively on antemortem trauma. So antemortem trauma is the type of trauma that you survived from. So healed fractures, basically, within a 20th century cadaveric population of Johannesburg. My main research questions were to see if there were any specific sex, demographic, and age groups that were more susceptible to trauma than the other groups. And also, is it possible to see if there are any behaviors associated with the trauma that I am seeing? So as a biological anthropologist studying trauma, there are certain approaches or theories you need to understand. And the first being the biomechanical approach. The biomechanical approach is the relationship between bone, which is both strong and quite flexible, with the forces acting around the bone. So in order to understand how bone reacts to pressure and to strain, we use Young's modulus. And Young's modulus traces or highlights the different phases in which bone will go through before it reaches its fracture point. At the beginning, it will go through an elastic phase. So you'll hit a bone and it's just going to bounce back at you. You won't see a mark on the bone from that force. Once you apply enough pressure, the bone will go through a plastic region phase. And that's where you get your indentations and bent markings on the bone. And if you continue to apply that constant pressure, eventually bone will reach its weakness and a fracture will occur. So that's how a fracture normally occurs in a bone. And of course, there are multiple forces that act on a bone. It could be tension forces, so pulling the bone apart, compression forces, which is pushing the bone into itself, and bending, shearing, or a combination of all these forces. And once a biological anthropologist understands the type of forces acting on the bone, we can then predict where the fracture occurs and how it did occur, just by looking at the bone itself. So that's the biomechanical approach. The second and third things that you need to consider are the clinical approaches. So the clinical approaches are your trauma behaviors, are what we are seeing in the bone a result of an accident, interpersonal violence, or is there an underlying pathological condition that has caused or attributed to this fracture that we're seeing? Another thing you need to consider is there evidence of medical intervention? Did this person get help for their injury or did they not? If not, why was this the case? Then one of the most important approaches that we need to consider is the biocultural approach. And the biocultural approach has three main components, that being culture or lifestyle, the environment in which the person lived in, and the individual themselves, the biology. All these three things work together to tell a full story of an individual. You cannot study trauma or pathology in isolation. You do need to consider the environment and the culture or the lifestyle of that individual. So here's a bit of a background to my collection that I looked at. I worked on the Raymond A. Cadaveric collection at the medical school at Wits. This is the largest collection of human skeletons in Africa. There are approximately 2,500 cadaveric skeletons. And if we add in the archaeological specimens, this would bump that number up to at least 3,000 skeletons in the entire collection. So the cadaveric collection began in 1924 by Professor Raymond A. And he was really into anatomy and he wanted to teach anatomy with real bones. So all these cadavers were collected from local hospitals in the Transvaal, as it was known then, and brought to med school for the med students to study on. So there are two types of cadavers that you get. These are bequest or donated cadavers and unclaimed or paupers. So these individuals were not, their families were not notified of their death, and they were just never claimed from the hospital. So their bodies got donated to the medical school. Or in some cases, the family did not have enough money to bury the body or to reclaim the body, so they were donated to med school. So you get two different types of cadavers, and these differences actually mean quite a lot when you're studying a population, and I'll show that to you quite later. So if you look at the demographic composition of the dark collection, 72% of the collection are South African Black individuals. 18% are South African white individuals, and a smaller percentage attributed to people categorized as Indian, Asian, or non-specific. So for my project, I looked mostly at South African Blacks and South African whites, because they're the largest bit of the collection. There's also 73% males in the collection, and only 27% of that collection are females. So there are more males than females in the dark collection. Now this makes you think, are there actually more men in cities than there are women? Or is this just the nature of cadaveric collections in general? So now we know the materials that I'm working with. So what methodology did I use to study the trauma? So the first thing I had to do was to identify the injured. So I went on this ambitious endeavor And I wanted to look at the entire collection. I managed to get through about 1,104 skeletons to look at, just trying to pull out which are the ones that had trauma on them. Once I had done that, I could then start recording where the trauma happens on the bone. And here I used some reference from Dobney and Riley and Keneiloe and Outram in the, I'll show you in the next slide, on the diagram that I should use to mark out where all these injuries are happening. And then later on, when I would interpret the patterns that I'm seeing, I would use a whole bunch of trauma books from leading authors like Alison Galloway, Steve Symes, Marina Stain, and Erica LeBay to help me interpret what it is that I was seeing. So, and then along with my trauma analysis, I wanted to do something a bit different, something relatively new in the game. And this was applying GIS, or Geographic Information Systems, into trauma analysis. So GIS is a database technology that records and analyzes spatial data attributed to a fixed point. And of course, we know that there are no skeletal templates in GIS. So that was a whole nother mission, which I will get to. But why did I use GIS? I wanted to use GIS because it could spatially link tabulated data. So it would bring my results to life in a very visual manner. So as I said, there is no skeletal template in GIS. I had to go into ArcMap and draw my skeleton by hand, convert it into a polygon, and I had my skeleton shape here. Then, because I needed a link, a spatial link for the GIS to understand which bone it is that I wanted to see, I had to code every single bone element with a specific code. So the humerus would be coded as 10. So both humeri would be 10. And then I had to differentiate between left and right. So because the humerus is split into, let's say, about 10 sections, so the humerus on the right would be 10.1, 2, 3, 4, 5, and then the one on the left would be 10.12, 13, 14, 15. So when I asked the GIS to tell me what's happening on the right humerus, it will show me codes for right and not left. This was a mission, I'm sorry. And this was what my results or attribute table looked like. Whole bunch of codes, whole bunch of frequencies. I wanted to look at sex, males, females, blacks, whites, young and old individuals. I looked at everything. I also calculated frequencies per individuals, per bone, and per part code, because I really wanted to get all the patterns that I could possibly extrapolate from the data. So what did my results look like? From the entirety of the dart collection, I think I actually looked at over 3,000 skeletons, but 60% of these individuals had antemortem trauma. So they had received an injury in their lifetime, and only 40% didn't have any bone trauma at all. If we look at the sex demographic, there was no statistical difference between males and females. Both were being traumatized in almost equal rates. Perhaps the men 10% higher than females, but there's no real difference. Both men and women are being injured. And if you think about it, that makes sense. You both have the capability of getting punched in the face or falling over the dog. Sex is not going to prevent you from falling over. Then I looked at the population group. I was expecting more more of a difference between these two groups. Even though South African Black individuals were more traumatized than white individuals, it still was not statistically significant. Again, both groups had the same potential to being injured. Another thing that I didn't consider at the time is the demographic of the dark collection itself. There are more Black people in the collection. So perhaps what I'm seeing here is a bias within the collection itself and not a true reflection of the trauma that is occurring. Then I decided, okay, so there's no difference between Blacks and whites and males and females in terms of being injured. What does this look like within the population itself? If you look at the South African Black population, there's almost no difference between the males and the females. Both are being traumatized in almost equal frequencies. But if you look at the South African whites, there's a huge difference, probably very significant, between the males and the females. So what this graph is telling me is that even though if you put males and females together, you don't see a difference, but once you tease out that data, you see that I'm looking at the working group of Johannesburg. I'm not looking at the affluent or the rich as well. And what you can also see is that males, they look like they're laborers. They have the same jobs in a way, but the women, there's a huge difference there. So the women are doing something very different from each other. Now, is this a true reflection of activities, or is it again a bias within the collection that there are just more Black women than there are white women? And this is possibly the only results table that I will show in this presentation because I use GIS like a boss. So this is just a table that highlights the ranking order of skeletal elements that were mostly fractured. So the most targeted bone was the crania, the skull, and this is followed by the rib cage, fibula, which is your ankle, the ulna, and the hand. And the least fractured element is the clavicle. Now, most people would be fine with tables as your results, but the GIS really brings the results to life. And I will show you that in the next slide. So here are my maps. So figure A was when I calculated the frequency or the prevalence of trauma according to each bone. So I had to account for any missing skeletal elements and work out how many of those had been fractured. And as you can see, the target area from skeleton A is the skull. If you wanted to injure somebody, you aim for the head. This is then followed by the ribs. And I was able to pull out data showing me that the middle range ribs was where the injury concentrated on. And again, this is followed by the ulna, which is your forearm. That was also a highly ranking skeletal element for injury. And this pattern tells me that, okay, I have some incidents of violence happening here because I have the skull, the ribs, and the ulna being injured. Those are all indicators of violent injuries. But then I also have things like the femur and the fibula being injured. Those injuries happen either due to a pathology or an accident. You twisted your ankle. So figure A is fine, but it's not giving me enough detail. It's not telling me exactly where the injury is occurring. And this is where figure B comes into play. And this map takes into consideration the part codes when I divided the skeleton up into various parts, and I could pinpoint exactly where the trauma occurred. And if you look at image B, on the cranium, the skull, the face is dominant as the most injured area, followed by the vault, the cranial vault, and there's a difference between the left and the right side. And then on the ribs, I'm also seeing that it is the body of the rib that is targeted, because that's the easiest to get to, right? And if we go down to the forearm on the ulna, I can see that it is the distal end of the ulna, which again supports my hypothesis that this is a violent injury. So this was just a general map for the entire collection. Then I did a deep dive looking at the differences between males and females. These two maps look very similar to one another. They're both getting hit in the face and on the cranial vault and on the ribs. So there are no differences between males and females. They're both experiencing violent injuries and accidental injuries as well. Then I looked at the trauma results on a population group basis. And even though the stats said that they're not significantly different, the pattern, however, tells a different story. If you look at the South African Black group, there is a huge concentration of facial and cranial injuries in comparison to South African whites. And they also have a lot more ulnar fractures than their white counterparts. And in the South African white group, we have a lot more hip fractures. So the pelvis and the femur are coming up very strongly. So is that an indicator of accidental trauma, or does the biology of the South African white group play a huge role in this? Because there is a bone density difference between the two groups. It's not a huge difference, but maybe it's enough of a difference to cause these fractures to happen in one group and not the other. Then I went into another deep dive with the South African Black group and looked at males and females. It's almost like the same map that I'm looking at, very few differences between males and females within the South African Black group. So now, am I looking at an environmental issue? Are these people living in very dangerous areas? Or are they doing very hard activity work that would cause these injuries that we're looking at? If you look at the South African white group, very different between males and females. In fact, look at the South African white female skeleton, and then I will show you the Black skeleton as well. Very different patterns of trauma. So again, this leads me to think very different lifestyles, either in the occupations that they're doing or the environments in which they're living in. So staying within the South African white population group, facial injuries are still a thing, probably more so in males than in females. And now this got me thinking, if you're getting hit in the face, I would assume, if you have an injury to your face, I'd assume somebody punched you. But at the time, I was not taking into consideration accidental injuries to the face. There are a lot of people that have broken their nose by accident, walking into a door or having a ball flung into their face. So facial injuries are very ambiguous. You cannot say for certain that they are violent injuries. They could be accidental, just like injuries to the ribs. You could fall over and crack a rib, or somebody could punch you and crack a rib. It's very ambiguous. It's either this or that. Without medical records, there's not much that I could say about these injuries. And then we had some lovely examples of interpersonal violence. These are 3 male skulls with beautiful circular cranial depressions. where you can see the pattern of the weapon that was used. So in my thesis, I hypothesized that what I'm looking at here are nopgiris, men being hit by a nopgiri. The shape is almost perfect. It's just a speculation. I'm not sure. Again, there are no medical records, and the skeletons can't come to life and tell me that, yes, somebody donut me with a nopgiri. I just have to assume this. Then we have some more beautiful cranial injuries. So the first skull on the top of the screen, this person had an unforgettable face. Somebody really went into him. And the skull below him is a nasal fracture. So again, this was very confusing. Did this person get punched in the face, or did they walk into a door and break their nose? I don't know. My favorite one is on the top right. This is a deep cranial depression. From the position of the lesion, if somebody was attacking this person, they attacked them from behind. But just based on what the injury looks like, it's high velocity. It's a huge force, and it's mostly accidental, I would say. There's no way a person would generate that much force to crack the skull this badly. So that's another thing to trauma analysis, is that you really need to look and feel the bone and think of all possible scenarios to come up with your conclusion. And here was the enigma. You'll see two cranial depressions on the skull. And my first thought was, this person got kicked in the head by a horse. But now I'm thinking, I mean, the shape was perfect. And then I was like, why would you get kicked in the head twice by a horse? Very unlikely. What we might be looking at here is a pathological condition, actually, called bilateral parietal bone thin-in. So this is not a case of trauma. It's actually a case of pathology. So this person had to be excluded from my analysis. Then we get to the postcranium. Some very beautiful examples of displaced trauma, probably a bumper fracture, as you can see from the tibia and fibula. This person might have been hit by a car and broke their shin bone. You have paired ulnar and radial fractures. This, I think, is partly due to a pathological condition. The individual had weak bones and they fell over and broke their arm. And then you have some examples of a combination between accidental and interpersonal violence. So we have the ulnar with a fracture at the proximal end. That is indicative of an accidental fracture. You fell over, put your hand out, and you broke your arm that way. And then on the distal part of that very same bone, you have two more fractures. And any fractures to the distal end of the ulnar is indicative of violence. So this person really went through a lot. They went through two incidences of violence and one accidental injury to one bone. And here's an example of how you should consider all the complete skeleton when you're analyzing for injuries or pathologies. If I had just looked at figure A, I would just say that, okay, this person broke their femur. They did get medical intervention because there's a surgical pin, and I wouldn't be able to paint any more of a picture with just that bone. But I did have access to his pelvis. So that's image B and C. And from that, tell that, okay, so I have a fracture to the iliac blade, 2 fractures on the blade, and 2 fractures on the pubis bones. And together with the femur, what this tells me is that this individual fell from a great height, landed on their legs, and shattered their hip. So all these bones are telling that one instance. If I didn't have the ilium, I wouldn't be able to come to this conclusion. Then we had some beautiful examples of surgery or medical intervention. This is a very simple amputation of the tibia, simple. But then we had some very complicated ones that I did not expect, which were quite interesting. So in figure A, you're looking at a tibia, and on it is a grafting site. So bone was removed from that area and transplanted to another region of the bone, of the body. At this point, I didn't know where this bone graft went, so I had to look at the entirety of the skeleton. On the vertebra, on the spine, in image B, when I put all the vertebral bones together, there was a kink in the spine. One of the thoracic vertebrae had collapsed, and this person probably had very bad back pain. Then I looked very closely at the spine, and I found the graft, which is in image C. They had taken bone from the tibia and placed it on the spinous process of this person's spine to try straighten and give support. Now, in modern surgery, you wouldn't put a bone graft on the spinous process, but you put it on the transverse process of the vertebra. So this is early evidence of playing around with surgeries, that trying to figure out what works and what doesn't. And of course, not only did I want to see if there are any differences between males, females, blacks and whites, I also wanted to see if the patterns of trauma that I'm seeing are linked with time periods. So I divided Johannesburg into certain political and socioeconomic periods. So we have the early years before Joburg was really Joburg, and it was a gold rush, and you had the South African War and the First World War. Then I looked at the apartheid period. And then finally, the popular resistance period from 1950 to 1979, which is where apartheid really came into full force, and you had mass segregations and a lot of political unrest. I looked at the data the same way. So separating out individuals according to by date of birth into the 3 periods that I was interested in. And across all 3 periods, the skull is, again, the focal area, followed by the ribs, and then the hands and the feet. What is misleading in this image is that the popular resistance group is so small. You actually can't make any comparisons. So I had to ignore the popular resistance period and just focus on the early years and the roots of apartheid. And just based on this map alone, there is a major difference that I'm seeing. There are a whole lot more hand and rib and ulnar fractures. So this is indicative of a change of lifestyle, a change from early farming communities probably to a more industrial lifestyle, going into the city, going into the mines, and taking on jobs that are more risky than the farming life. And again, this is repeated when I'm looking at detailed patterns of these injuries. there's a high concentration within the roots of apartheid period in comparison to the early years. So there is a shift in lifestyles just based on the patterns of the injuries that I'm seeing. So we're shifting from farming life to an industrial city Joburg life. So what did I learn from this whole experience? Trauma is not a rare or unique feature. Everybody has a potential to be injured. And there really is no huge prevalence between males, females, and the population group. Everybody had been injured, just in different ways, depending on how you're reading the data. Does the GIS work well as a visual tool? I think it does. I think it works better than tables and graphs can, because the maps really pop out at you. And are there any secular trends or long-term trends for the trauma? The devil is actually in the details. A lot more data needs to go into this line of investigation. One would need to consider the location where these people were living, really look into when they were born, where they were born, all these details that you don't get in a cadaveric collection. And again, these people can't come to life and tell me their life story. So you just have to work with what you've got. And with that, we have reached the end of my talk. Thank you very much.
Thank you so much, Kenny. That was an absolutely amazing presentation. You had me hooked from the very beginning. I've got so many questions and no, I don't have time to ask them all, but first and foremostly, I just want to commend you on your absolutely fantastic work in compiling a GIS skeletal map. You know, they're not having existed one before and you made one. I think on its own, that is commendable. You should have probably have received your PhD just for that.
Just for that, yes.
Just for that, like that was enough work. You can go now. Here's your red cap. Yeah. So is your skeletal GIS map available to other researchers who want to do similar work?
At the moment, no, it's not. It's part of the work that I'm doing now as a postdoc.
Mm-hmm.
So I'm getting all the publications in, and I will have that package ready, hopefully. But there is one that is available, not on human skeletons, but on animal remains by David Orton. I think I'll share that link. But I used Orton's work as a skeleton to my skeleton.
Yes.
And that's how I built the system. Yeah.
Okay, great. Yeah. And then there was another one. Okay. So our initial question was if you could see any, marked differences between white and black populations in terms of trauma. And like you said now, people had equal access to injury, it wasn't as if, there was like trends that you could really observe in terms of, racial differences. But what is interesting, particularly with trauma experienced by white females and there being a lot less trauma to the face, what I did see is there's a bit more trauma to the rib area, a little bit more. It doesn't stand out specifically, that there's a significant increase, but it seems like there's a bit of an increase. And I'm wondering if that's not part of, a social issue that we're seeing here in terms of white women being abused, physically abused, but their partners are very cognizant of not being exposed as abusers. So in that instance, you won't go for the visible features on someone's body. You won't hit them in the face. You'll kick them in the ribs type of thing.
Yeah, that is a possibility. Yeah. It's a huge possibility. But also, there's so few white women in the collection. You sort of have to think very carefully about it. And also, I think occupation as well plays a huge role. in it, because if we're being honest, Black women in the cities are domestic workers.
Mm.
So they're doing a whole lot more physical activities than white women are.
Yeah.
So one would also have to consider that.
Yeah. Yeah. And of course, white women lived a lot more guarded lives. I think that being probably the most fortunate of any demographic group would be white females, you know, because of social conditions. And then very interesting, also another final note, because I know Mpumi would have questions as well, is when you looked at the percentage of bone trauma throughout the different time periods that you looked at, you said that the popular resistance period had less examples to actually look at. And I'm guessing that kind of ties in with the apartheid era's covering up of crime. You know, I think of so many people who died during the apartheid era, their bodies were disposed of. You know, the authorities did not want people to know actually how many people were losing their lives during that period. So that's also completely, you know, if you can expand upon social issues, you know, that you can deduce from these skeletal remains, that I think that's a study on its own, you know, why you have so few examples from that period.
Yeah. I mean, and it's also not a case of just the government hiding the bodies.
Mm.
You didn't want your fellow Black person to land up in a white hospital for white doctor to study. Even if I didn't know Mpumi and she died, as a Black person, I would claim her body and we would bury it so that the white people couldn't study.
Yes. That's a very insightful point. That. So sorry, Mpumi, let me not hog our presenter any further. Please go ahead and ask your questions.
Thank you, Mariette. But I feel like you've also asked some of the questions that I did want to ask, which was the taxonomy on South African Black and South African white females, so far as the domestic abuse, that could have been an indicator of that. And also you covered my other question of actually making a GIS database, which was very fantastic. And I'm sure it must have been stressful because you have everybody encounters challenges with GIS, and now using it in a very different way. I mean, it's something to be applauded. So I'm happy about that. So actually, I have no questions to ask because we were on the same track, Mariette.
I'm so sorry, man. We should have had that telepathic connection better established this morning. I think there was a bandwidth issue with the telepathy. But Kenny, thank you so much. To our students tuning in, remember that there is going to be a pop quiz associated with each lecture. So keep an eye out for that. We'd like to track your activity on the Student Development Conference, and we'd like to engage with students as well. And if you have any questions related to this presentation or any other of the presentations, remember to contact us. We'll put you in contact with the presenter to share any other resources that they might have. And remember that we're all students. We're doing this. It's from students to students. And let's keep it fun and interactive and keep your eye out for the next presentation. Once again, thank you, Kenny, for an amazing presentation. Have a good day.
Thank you, guys. Thank you so much.
Bye.
Bye.
Bye.